College Algebra, Chapter 3, Section 2, Quadratic Functions and Graphs. Quadratic functions are polynomial functions, which we will discuss in more detail later. P is often used to represent a polynomial function. Now, a function defined by p of x equals ax squared plus bx plus c, where a is not equal to 0, is called a quadratic function. So we are talking about functions where the highest power on x is a 2, and it has to have that power. It cannot have just plain old x. Now, going back to the last chapter where we talked about horizontal and vertical stretches and shrinks and shifts, recall that g of x equals a times x minus h squared plus k is the graph of x squared that has been stretched or shrunk and shifted horizontally and vertically. The a would represent the vertical stretch or shrink, the h would represent the shift horizontally, and the k would represent a shift vertically. Now we've got two graphs here. The one is y equals x squared. The other is p of x equals 2x squared plus 4x minus 16. We can see that they're both parabolas. P of x is a graph of x squared that has been transformed through shrinking, stretching, and shifting. And we can see by the graph that it has been moved to the left, and it's had a vertical stretch, and it's been moved downwards. And we could probably count to see where the movements have been made as far as the shifting goes. The stretch would be a little bit more difficult. And sometimes you can't really count if the move has not been an integer. You may not be able to count where it has been moved. So the graph itself gives us some information, but isn't necessarily going to give us precise measurements for what has actually changed from x squared. But what we can do is we can take the equation 2x squared plus 4x minus 16 and put it in the form of y equals a times x minus h squared plus k, and we're going to use a process to do that called completing the square. Now again, this is a process that we have discussed in previous years, and coming back to discussing it now. We're going to look at the process of completing the square, starting with the expression p of x equals ax squared plus bx plus c. And the first thing we're going to do is divide each side of the equation by a so that the coefficient of x squared is 1. So now we're going to have p of x over a equals x squared plus bx over a plus c over a. Then we're going to add negative c over a to both sides, because we don't want a term without an x value on the right side of this equation, at least not yet. Then what we're going to do is we're going to add to each side of the square of half the coefficient of x. In other words, we're going to take that b over a, we're going to divide it by 2, which will give us b over 2a, and we're going to square that, and that's going to get added to both sides of the equation. Now at this point, what we're going to have on the right is a perfect square trinomial. So we're going to factor it as the square of a binomial, and on the left we're going to combine whatever terms we can. Next, we'll isolate the term that involves the p of x on the left by adding or subtracting whatever we need to get away from it. And then finally we'll multiply each side by a. Now I know it's hard to picture what's going on, so let's look at a few problems. So we're starting with p of x equals 2x squared plus 4x minus 16. The first thing we do is we divide everything by 2 because we want the number in front of x squared to be 1. We don't want another number there. Notice everything is divided by the 2, not just the x squared, not just the p of x, everything. The next thing we're going to do is we're going to get the 8 away from the terms with the x's. So we're going to move that to the other side. So we do not want a term without an x on the right side of this equation. Now what we're going to do is we're going to take the 2 in front of the x, and we're going to divide it by 2 and square it. So 2 divided by 2 is 1. 1 squared is 1, and we add that to both sides. So that's where the plus 1 comes from on the right and on the left. Then we combine the like terms, so we have p of x over 2 plus 9, and we're factoring the right side. The right side will always factor into a binomial squared. X plus 1 squared gives you x squared plus 2x plus 1 when you multiply it out. The next thing we want to do is, now our goal is going to be to try to get the p of x by itself, so we subtract the 9, and then we multiply everything by 2. And notice not just the x plus 1 squared got multiplied by 2, but also the negative 18. Now this is a form that we can tell a lot more information from about the graph itself. For example, we know that A is 2. A is what gives us our vertical stretch. So this has a vertical stretch of a factor of 2. We know that H is negative 1 and K is negative 18. Okay, that tells us that the graph has been moved to the left 1, and it has been moved down 18. It also tells us that our vertex is now negative 1, negative 18, because that's what was moved from 0, 0. Our axis of symmetry is x equals negative 1. Remember, parabolas have a vertical axis of symmetry that goes right down the middle, and the x value of the vertex will always be the equation for that axis of symmetry. So x equals negative 1 is the axis of symmetry. The domain is negative infinity to infinity, or all real numbers, as it is for any parabola. The range, normally x squared has a range from 0 to infinity, but this has been moved down 18. So it goes from negative 18 to infinity. And we know that it's decreasing from negative infinity to negative 1. Okay, we know that this parabola is opening up, and it starts by decreasing, and then it increases from negative 1 to positive infinity. Okay, we're going to transform this equation just like we did the last one. So why don't you try this one? Pause the recording, give it a try, and resume the recording to check your answer. Okay, so the first thing we did was we divided everything or multiplied everything by negative 1 in order to not have a negative first term. Then we moved the 8 over. We have minus 8. Next, we're going to take the 6. We're going to divide by 2, square it, and add that to both sides. So 6 divided by 2 is 3. 3 squared is 9, and that gets added to both sides. On the left, we're going to combine the negative 8 and the positive 9. And on the right, we're going to factor into x plus 3 squared. Next, we're going to move the 1 back over, and finally multiply everything by negative 1 to take care of that sign. Now again, what we can tell from this, it has a negative out front, so this parabola is going to open downward. In fact, it's going to be reflected across the x-axis. We know that it has been moved 3 to the left and 1 up. Its vertex is negative 3, 1. The axis of symmetry is x equals negative 3. So there's a lot you can tell about the graph just by looking at this form of the equation. Here's the graph itself. As we said, it's shifted negative 3, has a vertex of negative 1, 3 because of the shift. Okay, the coefficient, the a in front of the parentheses is negative, so it goes down, it opens downward. The y-intercept is 0, negative 8. And the axis of symmetry is the line x equals negative 3. The domain, again, all parabolas have a domain of negative infinity to infinity. In fact, all polynomials do. The range, because it's been flipped upside down, is going to be negative infinity to 1. It's going to be increasing from negative infinity to 3, and then decreasing from negative 3 to infinity. All right, let's look at the graph of p of x equals a times x minus h squared plus k. First of all, the graph is a parabola with vertex hk. The vertical line x equals h, as that is the axis of symmetry. And the graph opens upward if a is positive and downward if a is negative. The graph is wider than the graph of x squared if that number in front, if the absolute value of it is between 0 and 1, and it's narrower because it'll be stretched if it's greater than 1. One method to determine the coordinates of the vertex is to complete the square, which is what we just did. But rather than go through the procedure for every function, we can actually generalize the result for p of x equals ax squared plus bx plus c. So what we're going to do is we're going to look at what we get when we take just this general form with the a, b, and c in place and complete the square using it. Now this is going to look a little scary. Don't let it freak you out. It's going to be okay. We're going to make it a little easier, but we're going to look at the procedure first. Okay, like I said, a little bit scary. But what we did was we took this equation without numbers in it and ran through the whole procedure of completing the square. We divided everything by a. Notice they first changed p of x to y. That just makes it a little easier to work with. That's the only reason for that. We divided everything by a. Then we subtracted the c over a, the constant. Then it got really interesting because we had to take b over a. We had to divide by 2 and then square that. And that's the b squared over 4a squared. And we had to add that to both sides. Then we combined like terms. We noticed we didn't combine the y over a with that. What we did was we just combined the c over a and the b squared over 4a squared together. Gave them a common denominator. So what we have on the left is y over a plus b squared minus 4ac. That kind of sounds familiar. Over 4a squared. On the right, we have factored it. Then we subtract the b squared minus 4ac over 4a squared. And then finally, multiply everything by a. And also what they did was they changed it so we don't have that minus in front of the b squared minus 4ac. They carried that minus through. They made it plus. The minus and the minus in front of the 4ac became positive, and the b squared became negative. Wow. Okay, I know that looks like a really huge mess. And the good news is you don't have to memorize this. But notice that the a we end up with in front that tells us the factor of the vertical stretch or shrink. That's the same a we started with. So if we want to know what the factor is for the vertical stretch or shrink, just look at the front. It's that a. It's the same a. So that's good news. Now, the x value of the vertex, that's that negative b over 2a, which again sounds a little familiar. But that's really simple to remember. X for the vertex is negative b over 2a. Now the y value is that 4ac minus b squared over 4a, and that's kind of complicated. But the good news is you really don't need it, because if you know the x value of the vertex, negative b over 2a, if you know that value, you can substitute that into the equation for x and get the matching y value. So really what you need to know is that the x value of the vertex is negative b over 2a. And if you know that, you won't have to go through and change it to vertex form. You can take it right off the standard equation. Okay, we're going to use the vertex formula now to find the coordinates of the vertex of the graph from the standard form. Remember, the x value is negative b over 2a. The y value is what you get when you find that x value and substitute it in and solve. Pause the recording, give this a try, resume the recording to check your answer. Sorry, I may have done that a little quickly, so if I caught you, I apologize, but here's our solution. A is 3 and b is negative 2. So negative b over 2a means we have negative 2 over 2 times 3. The two negatives cancel out, and we have 2 6, which reduces to 1/3. So the x value is 1/3. Now, to find the y value, we're going to take the equation and put in 1/3 for all the x's. And that gives us a result of negative 4/3. So the vertex is 1/3, negative 4/3. When dealing with polynomials, we also like to talk about extreme values. The vertex of the graph of ax squared plus bx plus c is the lowest point on the graph if a is positive because it opens up, so the curve is at the bottom. Or it could be the highest point if a is negative because it opens downward. So the change in direction occurs at the top. These points are called extreme points. They can also be called extrema, and the singular for that would be extremum. Okay, so for the quadratic function defined by ax squared plus bx plus c, if a is greater than 0, the vertex, hk, is called the minimum point of the graph, and you see a picture there. The minimum value is p of h equals k. In other words, the x value tells you where the minimum is, the y value tells you what the minimum is. So if they want to know what is the minimum value, you give them the y value. When a is negative, we have a maximum, and that's going to be the vertex, that's going to be hk. The maximum value is k. So again, if they ask you what is the maximum value, it's going to be the y value, the k. Now we're going to give the coordinates of the extreme points and the corresponding maximum or minimum value for each function. So we've got 2x squared plus 4x minus 16. And remember, what we want to find is the vertex. So we're going to use the information that we've already talked about to do that. Pause the recording, give this a try, and resume the recording to check your answer. So the vertex is -1, -18. You find the x value by negative b over 2a. That gives you the -1. Put it in the equation and get -18 for y. Since a is positive, the graph is opening up, the parabola opens up, which means it has a minimum point. That minimum point is -1, -18, and the minimum value is -18. Now try this one. Pause the recording, attempt it, and resume the recording to check your answer. And we have a vertex of -3, 1. Because we have a negative in front of the x squared, this is a maximum point because the parabola opens downward, and the maximum value is 1. We can find these points on our calculator. I'm going to give you two techniques. One is you can use a function called fmin. Now what you do is you put the function in for y1, and then you go to the home screen. If you go to the math menu, you will see a function called fmin. And if you select it, it will open a parentheses. You're going to put y1, comma x. And then you're going to give it some boundaries to work between, -20 to 20. And it gives you -1. And then what they did was they said, okay, well, tell me what y1 of -1 is. And it gives you the the y value, which is -18. This is one way to do it. It's not a way that you've probably used before. The other way is what I'm going to show you now. You can use the min function on the calc menu. Now when you do this, it's going to ask you to provide a left boundary and a right boundary and then a guess. So when it comes up, you're going to hit the left arrow key until you get the cursor to the left of the minimum. Hit enter. Then you're going to hit the right arrow key till you get the cursor to the right of the minimum, hit enter. Then you're going to get it as close on to the minimum as you can and hit enter again. And at the bottom of the screen, you will get both the x and the y values. Now here, the x value says -0.99999. That's -1. Sometimes the way the algorithm works, it gives you something like that when it really should be -1. Just recognize that that's what that is, and notice the y is -18. Now, curve fitting is when they give us a curve and a couple of points and they want us to find the equation of the parabola. And this is actually not that bad. We have the vertex, which is 2, -3, and it gives us another point, which is 8, 69, and they want us to express it in standard form. Actually going to put it into vertex form first. So we're going to use a times x minus h squared plus k. We're going to put in 2 for h and -3 for k. And we don't know, so now what we don't know is a. So what we're going to do is use the other point they gave us, the 869, to find a. So we will put in 8 for x, 69 for y, and we will solve for a. And we find out that a is 2. Now we can put our equation together. We have p of x equals 2 times x minus 2 squared minus 3. We're going to square the x minus 2 by foiling it. Then we will multiply through by the 2 and finally combine like terms. Okay, the height of a propelled object. This is a practical application of quadratic equations because quadratic equations can often be used to express the trajectory of an object that is shot or thrown. If air resistance is neglected, the height s in feet of an object projected directly upward from an initial height s sub 0 feet with initial velocity v sub 0 feet per second is s of t, that's the height, equals -16 t squared plus v sub 0 t plus s sub 0, where t is the number of seconds after the object is projected. Now a couple things. First of all, t stands for time. In this case, the time is going to be in seconds. V sub 0 is the initial velocity. In other words, how fast was it going at the start of this? S sub 0 is how high was it at the start. The -16 is a constant based on the gravitational force of Earth, and it's going to vary on other surfaces. Like if you were to shoot the same object upward on the moon, you would have a different number there. So you have a ball that's thrown directly upward from an initial height of 100 feet, that will be our s sub 0, with an initial velocity of 80 feet per second, that will be our v sub 0. Give the function that describes the height in terms of time t. Okay, as we go through these, pause the recording in between the questions and see if you can do them, and then resume it to check your answer. Okay, all we did here was we put in our v sub 0 and our s sub 0. Next, graph the function. Okay, there's what it looks like. Notice that our x is going to start at 0. So is our y, because that makes the most sense. X is going to represent time here, and you don't have negative time. Y is going to represent the height, and we don't have negative height unless you're going below the ground, I guess. This actually should be C. I'm not sure why it says A, but the cursor in part B is at the point 4.8, 115.36. What does this mean? Well, 4.8 represents the time, and 115.36 represents the height. So after 4.8 seconds, the object will be at a height of 115.36 feet. After how many seconds does it reach its maximum height? Well, the maximum occurs at the vertex. So x equals -b over 2a. Our x value is 2.5, so it's 2.5 seconds. And then to find out what that height is, we put that into the equation and solve for y. So after 2.5 seconds, it reaches the height of 200 feet, which is its maximum height. For what interval of time is the height of the ball greater than 160 feet? Well, this is pretty easy to do, especially on a graph. If you put a line at y equals 160, then you can find the two spots where it intersects, and it is greater than 160 feet between 0.92 seconds and between 4.08 seconds. After how many seconds will it fall to the ground? Well, the ball is going to hit the ground when the height is 0, so we need to find the positive x-intercept. We need to find what x is when y is 0. From the graph, it's about 6.04. So at about 6.04 seconds, it's going to hit the ground. All right, the rest of this video is going to be some problems for you to try. Give each a try, pause the recording, and then resume the recording to check your answer.